Our lesson today is on page 49 in your notes package. We're just going to do a review lesson today to kind of put together everything that we have learned about polynomial functions. So the first example asks us to graph the function of x cubed minus 6x squared plus 6x plus 3. So if you take your graphing calculators, enter that into your y1, x cubed minus 6x squared plus 6x plus 3. Okay, and ask it to graph. All right, I'm just going to adjust my windows because right now I would like to just be able to see a little bit closer on my x-axis, so I'm going to adjust it to -5 and is my minimum, and +5 as my maximum, and just see if I can get a little bit closer up so that it's a little bit easier to read what my x and y are, or sorry, what my x-intercepts are. Okay. Let's draw a sketch of that. So we need our x and y axis. Now, right now I can tell by looking at this equation what my y-intercept is going to be, because remember that will be, when my equation is in standard form or expanded form, it is the value of my constant term. So my constant is 3, that means my y-intercept is 3. Okay, so I can put a point on my graph at that point. 1, 2, 3. That means I have a y-intercept at 3. At this point, I don't know what my x-intercepts are. It's a little bit hard to tell from this graph because it doesn't look like they're lying right on -1 or right on +2 or on +4 or 5. They're in between. This tells me that I'm going to have to use my calculator to calculate what those x-intercepts are. Now, if you remember, another term for x-intercepts is I'm looking for the zeros of this function. Okay, so when I ask my calculator to calculate that, I'm going to go second function of trace, which is calculate a 0, and I need to ride around to the left side using my left and right arrows and hit enter, and then just go just a little bit past it and hit enter 2 more times, and it tells me that when y is 0, my x is -3.6. I'm going to round that to the nearest tenth, so -0.4 would be the first x-intercept. Okay, if you do that and calculate your next x-intercept the same way, you'll have to go back into second, calculate another 0, and then again use your right arrows get close to it without having to be right on top of it. So as close to it as you can, and then go past it, just a little bit past, and again hit enter 2 more times, and it tells you that when your y is 0, your x is 1.8. Okay, do that process 1 more time to get your farthest right 0. So second, calculate a 0. That's number 2. Okay. And again, ride your cursor around. You can probably do it a lot quicker than I can on the smart board. I'm just showing you the first one. You'll be doing the others yourself. And just get past it. And we have a 0 at 4.5. When y is -2e to the -12, that just means times 10 to the -12. So that's, if you move that 0 or that decimal 12 places to the left, it would be 0.000000, 11 zeros and then a 2, so it's very close to 0. So when your y is 0, your x is 4.5. Okay, now that we have our 3 x-intercepts, we can plot those points on our graph. So I've got one at negative 0.4. So if I continued 1, 2, 3, 4, 5, 6 this direction, and the same equal sections each direction, negative 0.4 would be not quite at half, so that's about right there. And then 1.8 is not quite at 2, and then 4.5, 4.5 would be right about there. Okay. Now I do know the degree of this function. I know that it is degree 3, which means that the shape I should be expecting this graph to take is this general shape. Okay. I also know that it has a positive coefficient, leading coefficient of 1, which means that this graph is going to, its end behavior is that it is rising. So it's going to be starting in this quadrant, quadrant 3, and it's going to go up through this first 0 of negative 0.4. This is, it's going to go up to this y-intercept, then it's going to come back down through the next 0, and then back up through the third 0. So something like that. That's a rough sketch. Okay. So we can fill in now what our domain is. Domain is all of the values of x that make this function true. Well, x could be any element of real numbers, as we can see, because our x's are not even whole numbers, they're decimals, so that when we say x is an element of real numbers, it means all the little values even between all the whole numbers. So those are fractions, decimals, 0.4, 0.5, 0.6, 0.7, all of those values are included in that x, aren't they? Okay, and then our range, same thing, our y's are all elements of real numbers. Okay, the only other thing we have to answer on this is the coordinates of any maximums or minimums to the nearest tenth. Okay, so if you remember before, when we have a cubic function, we have often get a function that has right here a local maximum and right here a local minimum. So that's what it's asking us to calculate. Now it almost looks like our local maximum would be our y-intercept, but it's actually not. It's just slightly to the right of our y-intercept. So let's see if we can calculate that maximum. If you remember how we do that, it's the second. So I guess I need to clear this. We go to second function of trace. Whoops, let's just go back to our graph. Okay, so we wanted to calculate a local maximum. So we're going to go second function, calculate. We want the maximum. That's number 4. Again, use your left and right arrows just to get to the left of the maximum, and then to the right of the maximum. And then hit enter 2 more times, and it'll tell you that your maximum point is at 4.65 on the y. Okay, so that's your maximum point. It asks for us to write this as coordinates. Okay, so it's coordinate pair. So that means we need our x and our y. So we're going to round them to the nearest tenth. So that's the first place after the decimal. So our x would be 0.6 when our y is 4.7 is what it would round to. Okay, that's our maximum point. Then you would do the same thing to get your minimum point. Okay, ask it to calculate second function. Oops, clear it, I guess. Second function, calculate minimum point, number 3. Okay, write it around Okay, and you go ahead and do this. When you get your answer, you can resume the video. Your minimum point, your x is 3.4 if you round to the nearest tenth, and your y would be negative 6.7 rounded to the nearest tenth. Okay. I would like you to pause the video, do all of the calculations for the second example exactly like we just did. This is written in expanded or standard form. It doesn't have a constant term at the end. Does that mean that there is no constant term? Right, it really means plus 0, right? So what that tells you is your y-intercept should be 0. Okay, plug that into your calculator, figure out your domain and range, figure out your x-intercepts and how many there are, and then we'll resume the video and you can check your answer against mine. Okay, you should have got this graph when you graphed it. The behavior that we see happening is that this graph has an x-intercept at 0 and another x-intercept at 2.5. The behavior at this graph at 0 is that it touches that point, then it bounces off, and then it goes directly through at the x-axis at 2.5. Your local maximum, that's this point here that you calculated, should have been 1.7 as your x and 4.6 as your y. Your local minimum is actually this point right here, which is one of your x-intercepts. And if you round that to the nearest tenth, you would have to list that as 0.0 as your x and 0.0 as your y, because it asks for it to be listed to the nearest tenth. So not just 0, but 0.0. Okay, flip over the page. There's one more for us to try on the next side of the page. It says, without using a graphing calculator, make a rough sketch of the graph of negative x times x minus 1 squared times x minus 4. Okay, this is lovely because they have put it in factored form for us. First of all, what degree will this function be? I have x times x squared times x. Right, that will give me a function x to the 4th, right? Which means this is a quartic function. Quartic is what you call functions to the 4th degree, okay? Degree 4. Okay, let's identify the x-intercepts then. When you look at this, you can see 3 factors, right? You see this factor here, you see this factor here, and you see this factor here. Each one of those factors has to be set to 0 to figure out what x equals. So negative x has to equal 0 because that is one of our zeros of this function. When I divide both sides by negative 1, I still have x is 0. So I have an x-intercept at x equals 0. Then if x minus 1 is another one of my zeros, I solve that for x equals 1. And my third 0 is x minus 4, and that will solve for x equals 4. Okay, so now I can plot those 3 x-intercepts. I've got an x-intercept at 0, I've got another x-intercept at positive 1, and I've got another x-intercept at positive 4. Okay, now from the factored form of this equation, I can see some behaviors. I can see that at the point where x equals 4, I have a multiplicity of 1. That factor is only being used one time, which means my graph is going to go directly through that point with a straight line. However, at the value where x equals 1, I can see that it has multiplicity 2. That's where my graph is going to touch, the line is going to touch the x-axis at 1, but then it's going to bounce away. I also can see that at 0, it's only using that factor one time, and so the line is going to go directly through the x-axis at 0. Okay, now if this is quartic, if this is a degree 4 function, this is an even degree, which tells me that both arrows, at the beginning of the graph and at the end of the graph, are going to be pointing at the same direction. Will they be pointing both arrows up, or both arrows down? Where do I get that information from? Right, the fact that this is a negative coefficient of x tells me that both arrows will be pointing down. This graph will be opening down. Okay, so this graph is going to start here. It's going to go directly through at 0. Then it's going to approach 1, but then bounce away. It's going to go way up here to some point way up here. And then it's going to come down and end with my arrows pointing down just like they started. Okay, now we're going to flip over a couple of pages to page 57 as our next page. Because your book is a little bit out of order, there's one more page we're going to do today of these types of questions. So, page 57. Okay, and it looks like this. Determine a cubic polynomial function with the given zeros. Leave it in factored form. Oh, we're very good at this. This should be easy for us. That means we have to write it as a function in factored form. Okay? If I have a 0 of where x equals 1, then the factor that leads to that is x minus 1. Right. And if my next factor is x equals negative 2, that's x plus 2. And if I have a factor where x equals 4, that's x minus 4. Okay, and that's all that question is asking us to do. Okay, now I have another function. It is also cubic, which means I'm going to have x cubed. So I do need to just double check and make sure that if I multiply this out, I've got x times x times x. That is going to give me an x cubed function, a cubic. Okay. Now, this one, I only see 2 zeros, but one of those zeros has a multiplicity of 2. Okay, so this would be p of x equals, well, to get the 0, right, that's an x just in front that equals 0, right? My other factor would give me x equals 5, so that's x minus 5. But that factor has a multiplicity of 2, so that means that factor is squared. Okay. When I double check this now to see if this will give me a cubic function, I have x times x that has been squared. So x squared times x.
We have all been stopped. Please make your way down to the den. We will be spending the final portion of our day together.
Okay, the last one, I have 3 zeros. I've got 1 at 5, so that's p of x equals x minus 5. 3 halves. Okay, so I have to work backwards in my head to figure this one out. If my x is going to equal 3 halves, okay, so now I'm going to multiply both sides by 2, so I've got 2x equals 3. And then I'm going to subtract 3 from both sides, and that equals 0. Okay, so 2x minus 3. And I'm going to have to do the same thing for negative 3/4. That means my x equals negative 3/4. Okay, so now I'm going to multiply both sides by 4, so I get 4x equals negative 3. Then I'm going to add 3 to both sides. 4x plus 3 equals 0. 4x plus 3 is my last factor. Okay, when I check this to see if this will give me a cubic function, I'll have x times 2x times 4x. That's going to give me x cubed, 8x cubed actually. So that will be a cubic function. Okay, we are almost done. This time we have a quartic polynomial function. Remember, quartic means degree 4. Okay, and I've got some zeros here. So I've got a 0 of 2. So that's going to mean x minus 2. But that has a multiplicity of 2. It's being used twice. Then I have my next factor gives me x equals negative 3. So that's x plus 3. And I have another factor of 4 where x equals 4. So it's x minus 4. When I check that, I'm going to have an x squared times x times x. That's going to give me x to the 4th, which is quartic, right? Okay, same thing here. P of x. I've got one factor that is 0. That's just my x out front that equals 0. I've got another factor that's going to give me x equals 3. So that's x minus 3 with a multiplicity of 2. And then I've got x equals negative 1. So that's x plus 1. Again, that's going to give me multiplicity of 4 because x times x squared times x. All right. And this last one, we're going to have p of x. Now I've got one x that equals 0, so that's my x all by itself up front. One x that equals negative 4, that's x plus 4. And one x that equals negative 5/4. So let's see, negative 5/4 equals is my x. So I'm going to multiply both sides by 4. So I'll have negative 5 equals 4x. Then I'm going to add 5 to both sides. So I've got 4x plus 5. Okay, 4x plus 5. Okay, I think I'm done. But when I double check this one, I notice that if I multiply this, I've got x times 4x. That's only going to give me x cubed. That's not going to give me a quartic function, a degree 4 function. So that tells me that I need to have multiplicity 2 on one of these factors. The only factor that I can give multiplicity 2 on without changing the value of the function is my 0. So it's going to be x squared here. Because if I square this one or square this one, it's going to change the value. But if I square the 0, it doesn't change the value. But it does give me an x to the 4th function, a 4th degree function. Okay. A quadratic function has a vertex at 2 and negative 3 and a y-intercept of 9. We have to determine the function. That means the equation for the function. Okay. So I know in vertex form that the vertex would be hk. Remember that form that we looked at a few days ago? Vertex is hk in this formula. Y equals a times x minus h squared plus k. Okay, so let's plug in our vertex. This will be my h and my k in this formula. I also know one other point in this on this graph, and that's my y-intercept. I know what those coordinates would be of that point. The y-intercept is the value of y when my x is 0. So I need to make sure I write 0 for the x. Remember, it always goes x, y in that order. Okay, so now I can use these points. I'll use these as my x and y, and I will use these points as my h and k, and that will help me to solve for a. Okay, so when I do that, my y is 9, my a is what I don't know, my x is 0, my h is 2 squared, plus my k is negative 3. Oh, so I don't need to say plus negative 3. I can just say that's the same thing as saying minus 3. Okay, do you see how when I have written h and k above here and x and y above here, it takes the guesswork out of trying to figure out where to plug them in the equation. It just makes it a little bit easier to plug in. And I would advise or recommend that you do that just to make it easier for yourself. Okay, when you solve this, you've got 9 equals a times, what's 0 minus 2? negative 2 squared minus 3. Okay, we're going to finish this over here. I've got 9 equals negative 2 squared is positive 4, so I've got 4a minus 3. Add 3 to both sides, so I've got 12 equals 4a. And then divide by 4 on both sides, and I have a is equal to 3. Now, once I have my a, then I can go back to this formula, and I'm going to plug in my a, and I'm going to plug in my vertex, because this is the vertex form, so I need my vertex and my a, and I'll have my equation for the polynomial function. Okay, so going back to this equation, y equals a times x minus h squared plus k. I'm not going to plug in a y because I know my equation has to be in terms of y equals, or the function of x equals. That means the same thing as y, right? P of x or f of x means the same thing as y. Okay, but I do know my a now. I can plug that in. A is 3. X minus, now my h, go back to here. I'm plugging my vertex into my vertex form. So my vertex, the h is 2 squared, and my k is negative 3, so plus negative 3 is minus 3. Okay. Now, unfortunately, I can leave it in this form because this does give me the equation in vertex form, but most of the time they want us to expand that. So to expand that, you would actually go, I'm going to do it over here just because I've run out of room. I hope you have a little bit more space than I do. Y equals 3 times x minus 2 times x minus 2. That's what x minus 2 squared means, right? Minus 3. So y equals 3 times, let's FOIL this x minus 2 times x minus 2. That's x squared minus 2x minus 2x plus 4, and then minus 3. 3, I have to multiply this 3 times each term in this bracket now. So that's 3x squared minus 6x minus 6x plus 12 minus 3. Y equals 3x squared. Now I'm going to combine these x terms. I've got negative 6x minus 6x, that's negative 12x. And then I've got plus 12 minus 3 is plus 9. Okay. So this will be my expanded form, 3x squared minus 12x plus 9. Okay, so when you have information given, if it tells you you have the vertex, use this formula, the vertex formula, okay? Plug in your, remember that your vertex is hk in your formula, so plug in your h and your k. Use any other point that it gives you. In this case, it gave us the y-intercept, so we knew our coordinates. Use that as your x and y. That will give you your a. Once you have your a, go back to the original formula, plug your a into the original formula, and because we were using a vertex form, plug your vertex in to the original formula. Okay? And that will give you your equation, this one. But most of the time they'll say put it in expanded form, so you just multiply it out to get expanded form. All right, next one says a cubic function. Now this is a typo, so could you just scratch out the word cubic here? Because that should not be there. A function has zeros, negative 3, negative 1, and 2. The y-intercept of this graph is 12. Determine the function. Okay, so the function then would be, let's see, if we have 3 zeros and the first one is x equals negative 3, that's x plus 3. The second 0 is x equals negative 1, so that's x plus 1. And the third one is x equals 2, so that's x minus 2. Okay. Now the problem is, when I look at this, and I notice that my y-intercept has to be 12. But remember, if we multiply these constants, we're going to have 3 times 1, which is 3, times negative 2, which is negative 6, not 12. So something is wrong with this. If I multiply this out even, maybe when I put it in expanded form, maybe I'll see that I have a y-intercept of 12. Okay, so let's do that. Remember last day we learned that when we have 3 binomials, 2-factor, we're going to leave the first one exactly as it is, and we're just going to FOIL these two first to start. So I've got x squared minus 2x plus 1x, so that's negative x, minus 2. Okay, now to multiply this binomial by this trinomial, I have to take the x and I'm going to multiply it by each term in this bracket. So I've got x times x squared, that's x cubed, x times negative x, which is negative x squared, x times negative 2, which is negative 2x. Then I'm going to do the same with this 3. I'm going to times 3 by each term in this bracket. So 3x squared minus 3x minus 6. When I combine like terms, I end up with x cubed. Then I'm going to add my x squareds. I've got negative x squared plus 3x squared is positive 2x squared. Then I'm going to combine my x's. I've got negative 2x minus 3x, that's negative 5x, minus 6. It's just like I thought. I end up with a y-intercept of negative 6. This cannot be. My y-intercept is 12. Okay, so right away I need to say, there's something going on here that is going to double this function somehow so that this negative 6 ends up being a positive 12. Let's make a note to ourselves here. This function has a y-intercept of negative 6, not positive 12. How can I multiply by another 2? How can I double it? Well, let's look right back at our factors. Look right back here at your factors. And think about what we know about the factors of an equation. I'm wanting to multiply the whole thing by 2. What if I had multiplicity 2 on this factor? Then, when I multiply my constants, I've got positive 3 times positive 1, that's 3, times negative 2 squared, that's 4, positive 4. So I've got 3 times positive 4. That's going to give me a y-intercept of positive 12, right? So when you are finished, like I said before, always, always, always check this against what you know. This says the y-intercept has to be 12. This is not giving you a y-intercept of 12. An alarm bell should go off and you should say something is wrong with this equation and how can I make it right? Okay, just like that other one the other day where if we didn't have that negative sign in front, our graph was opening in the total wrong direction, right? So those kinds of things you need to be aware of when you're doing these questions. Now, if you actually wanted to check this and just see if we were right when we made multiplicity 2 on this factor of x minus 2, you could plug that into your graphing calculator. You could plug the factored form right in there and see and you will actually get this graph. Let's see what we would expect it to be. We'll do a rough sketch, and then you can check it with your calculators. We know there's going to be an x-intercept at -3, so right about there. There's going to be an x-intercept at -1. There's going to be an x-intercept at +2. Okay, now if that +2 is squared, we know that it's going to be touching that point and bouncing away. The other 2 points, the line will be going directly straight through. Okay, this tells us that we have an x times x squared. That's going to be x to the 4th, degree 4 function. Okay, so this function, and it should have a y-intercept of 12. This function is degree 4, so we would expect both arrows to be pointing in the same direction, and it's positive, so we should expect it to be both opening up. So it's coming from up here. It's, oh, where did my graph go? Sorry, I'll try that again. It's coming from up here. It's going directly through this point, bouncing up to this point, y-intercept up there, but when it hits this, it bounces off and goes back up. It doesn't go through the x-axis at that point, +2. Now, if you just graph that on your graphing calculator, you will see that we were right. Okay, that is the end of our lesson for today. There is homework though, because I think that some of us need some time to go through our book and make sure that we have completed all of the assignments to date. And so if you have not yet, this is your chance to do this. Use the remainder of this class to finish any assignments that you need to work on in this book. Please, for sure, make sure that you have done many of these kinds of questions, like this example here, where we had to use the equation to solve for A and then plug the A back into the equation. Those assignments are really, really important. That was page 28, 29 in your book where you had practice doing that. So please make sure that you have finished all of those so that you're comfortable doing that and you know how to solve for A. Make sure all of the assignments in your book up to this point have been completed, because tomorrow we are going to be looking at applications of polynomial functions on page 52 and finishing that last section, and our test is going to be Wednesday. Okay.